Now I'll tell a little bit about x86-64. I'm also going to show you how to do the swap example we saw in the previous video, but now with x86-64 instructions as opposed to the 32-bit instructions. Okay, so x86-64 has 16 registers. Okay, and just like IA32, there's some registers that have a special use, but there's a lot more general purpose registers. Like all of these registers here are only present in the 64-bit version of x86. And also know that while these registers are 64 bits wide, you can also access the lower 32 bits of them as a register as well. For example, EAX, which is also present in IA32, is the low order 32 bits of register RAX in x86-64. Okay, so the way to look, one way to think about it is that we're extending existing registers to 64 bits, plus adding 8 new registers. And now the way we look at operands in 32 versus 64-bit mode is the following. Remember that we had in IA32 we looked at move L, and L referred to moving 4 bytes worth of data. Now what we have in x86-64 is move Q. It's a new type of data size that is 8 bytes or 64 bits long. Okay. Now we also have other instructions like add L that's present in A32. Now we have add Q, and then shift L, which has shift Q, and so on. So and also note that x86-64 can also use all of the 32-bit instructions that generate 32-bit results. Okay. So, and like I showed in the previous slide, we can reference the low order 32 bits of some 64-bit registers with the same name as we use in the 32-bit ISA. Okay, and the high order 32 bits are set to 0. Here's the example that we saw in the previous video. We had this swap function that received 2 pointers, xp and xy, as parameters, and then it swaps the contents of these pointers. Okay. Remember that these 2 instructions here, what they were doing is they were reading the pointers that were stored in the stack, because parameters in the IA32 IA32 ABI is passed via the stack. Okay, so that's one thing to note. And we've used all move L instructions because we're moving 4 bytes worth of data. Okay, so now let's look at how this piece of code will look like in 64 bits. Okay, but the first thing to note is what we have: move L, 4 of them. And also note that we are passing the parameters via registers. Okay, so directly as opposed to the stack. So XP, the XP parameter, is stored in register RDI, and YP is stored in register RSI. And these are 64-bit pointers because addresses in x86-64 are 64-bit long. And look how interesting. Now we have only 4 instructions. We're no longer reading the parameters from the stack, which is a big advantage, right? So it's much faster. You don't have to store it to memory and read it back. And we have much fewer instructions. And now here what we're doing is this first instruction gets the contents of of XP and stores it in a temporary variable, in this case T0, right? That happens to be mapped to EDX. We get YP, its contents, right? That's why we're using the parentheses here. We're dereferencing the address, storing it in the other temporary variable T1 that happens to be mapped to EAX. And then we're just storing the temporary variables back into the pointers, and then we return. It's much simpler, right? And because the main reason it's simpler is because we don't have to use the stack at all. No stack operations required. And note that we still moved 32 bits worth of data. Why is that? Well, because this integers here happens to be 4 bytes long. Even though the pointer itself is 64 bits, the unit of data that it points to is a 4-byte integer. And we also used move L still because we're moving 4 bytes worth of data. We're still using the same type of instructions. Now, suppose that we had long ints. Now, if you're saying long ints here, we're saying that the unit of data is 8 bytes. Okay? If the unit of data is 8 bytes, now the move operation itself has to be 8 bytes long. Remember that Q refers to 8 byte words. Okay? So, and now since the long int is 8 bytes as well, we have to use move Q instructions. Okay? So, all right, see you next time.